Okay, we're going to have a little look at determining quadratic rules here, which is a work we started on in class, and trying to use the clues that are given to us in a graph to find the equation of the quadratic. So let's just have a look at some examples here. We'll go to, we're on page 133, and if you have a look at question 5D, we might just talk through that one initially. So the information we're given here is that we've got a quadratic that does something like that, dips through here at 3 and 1 and 3 here, and so by starting with y equals ax squared plus bx plus c, we don't know the vertex. If we did know the vertex, it would possibly, and looking ahead to E, so we've got the vertex there, I think we'd use the vertex form of this equation to start with, because that would make life easier. In this particular question we don't, so I think starting here is going to be good. We know straight away that c equals 3 because the y-intercept is always equal to c, so we can improve on this to say that y equals ax squared plus bx plus 3, because it goes through 3 on the y-axis there, x-axis, y-axis, should label my axis. Okay, so that's that bit of information there that provides us with that step. This point here, 1, 0, we can put that in. Let's put that in to this equation, so we get 0 equals 1 for a, so it's a, 1 for x, so that just leaves us with a, 1 for x here, leaves us with b, plus 3. That gives us an equation, equation 1, and the point here 3, 0, let's use that also. So 0 equals 3 goes in here for x, so that's 9a. And we're putting these points into this equation here. 3 for x here gives us 3b, and there's a 3 on the end. We can divide through by 3 here to improve on the situation. 3a plus b plus 1. And they're going to call that equation 2. Okay, let's have a look here. Now I've got 3a, I've got b and b, so I reckon if I say take equation 2, so think about this, and subtract equation 1, then what's going to result? I think these b's are going to disappear, which would be great. 0 minus 0 is just 0 there. 3a minus a is 2a. b minus b gone. 1 minus 3 minus 2. So we end up with 2a equaling 2, or a equals 1. Now if a equals 1, b is going to equal, well, 1 plus 3 plus b, so b will be equal to minus 4, and therefore our equation is y equals x squared minus 4x plus 3. Putting in 1 here, minus 4 for b, and 3 we found out first up. So there's our equation for D. If I have a look at E, and then perhaps you can have a go at F yourselves. In fact, if you have a look at E now, this would be better. You try and do it yourself. So pause this video, do it yourself, and then come back to it to see if you've got the same as me. So hopefully you've now just rejoined us. If you haven't, it's time to pause it so that you can test yourself on this question. So we've got a concave down parabola, does something like this. Probably not very to scale, but that's okay. Minus 3, 0 here. The vertex is minus 1, 5, they're telling us. Now because this is it's a 5. Because this is in vertex form, I think it might be wise for us to start with y equals a x minus h squared plus k. Now vertex is hk, and a is just, we have to account for some constant value here that might be changing the shape of our parabola. So that's a good starting point. Oh, that wasn't so clever. So we can now put straight in, we can put this minus 1, 5, we can put that straight in, so that into h and k. So y is equal to a x plus 1 squared plus 5. So now it's only A that we're missing, and I can find out what A is by just putting in one of these points. I'm going to put in 1, 0 to here. So 0 equals 4A. So I've got 4 by putting 1 in there. 1 plus 1 is 2. 2 squared is 4. 4A plus 5. So A is equal to minus 5 over 4. So now I've got an equation that looks like this. Y equals minus 5 over 4. X plus 1 squared plus 5, and we're done. We could expand this out, etc., but I'm happy with it exactly how it is there. Now it's time to pause again. If you're going to take on F, which I hope you do, take on F without my help. Pause now. Okay, welcome back. F looks like this. We've got a parabola that dips down through 6, doesn't go through the x-axis, so we've got a 2, 2 there, goes through here at 6, which also happens to be at 4, if that's any use to us. I'm not sure if it is. Now if we use 2, 2 as our starting point, so y is equal to a by x minus h squared plus k. hk is my vertex, so I've got x minus 2 squared plus 2. Now I can put in 6 or 0, 6 here, so I can put in this point now. 6 for y and 0 for x, so that's 0 for x, and then minus 2 squared is 4, so it's 4a plus 2. So 4a is now equal to 4 and a is equal to 1. So my equation looks like this. I can now put in 1 here, so it's not going to affect it. H, and if you wanted to, x squared minus 4x plus 4 plus 2, it would look like that. But I'm quite happy with it in that form. That's okay, and that's okay. So that's using the vertex form. If you have the vertex, is quite easy. If you don't have the vertex, then substituting in points with a starting value there where C becomes your y-intercept, hopefully you've got that, and you've always got some other points that you can create some quadratic, some simultaneous equations with in order to find out your A's and B's. Okay, have a look now at questions. What I'd like you to do off the work requirements, but I'll say rather than doing 9, I would like you to do, it says 6, 8, 9, 17. I'm going to say questions 6, 7, 8 and 17 for tomorrow. Okay, see you then.